MultiVision is a camera and software system that enables the CNC machine to see printed images. By itself, the machine can easily cut out vectors according to job files, but the machine cannot easily line up a cutout line to a printed image without seeing it first. To understand the problem better, imagine wearing a blindfold while you're trying to cut out a 6-inch square that is 1 inch from the edge. Even though you could probably locate the square and use a straight edge to help cut it out, it would still be very difficult to cut out the image accurately. Now, imagine if the printed square is slightly skewed from the edge and no longer a perfect square. With a blindfold on, it would be just impossible to accurately locate and cut right on the printed edge of the skewed shape. MultiVision not only removes the blindfold, but it figures out the skewed imperfections so that the printed image can be cut right on the line. Actually, the MultiVision camera doesn't see the picture of a printed graphic at all. MultiVision is programmed to find the center of a high contrast circle that is about 1/4 of an inch in diameter. These dots are called fiducials, or registration dots, that are printed at the same time as the graphic. The camera takes a snapshot of an area where the dot is supposed to be, finds the center of the dot, and then compares that location of where it actually found the fiducial to where it was supposed to be in the graphic. Using some fancy math, the cut line is remade on the fly to match the print laying on the table. The first step for the graphic artist is to take the final image to be printed and create a cutout line or die line around the image. This image will need to be at actual dimension when creating this path for the cutter to follow. The artwork and cutout line should be saved to separate layers because, in most cases, the cutout line is not printed with the image. Next, the graphic artist must create and drag into place 1/4 inch solid black circles for the fiducials. It should be noted that some RIP software can automatically create and print fiducials for MultiVision, but for training purposes, we will use the manual way. The most common questions regarding fiducial creation and their placement basically boil down to how many and where. Here are some basic rules and suggestions. Fiducials need to have about 1/4 of an inch perimeter around the outside of the dot, not touching the graphic or the edge of the sheet. This greatly helps the camera to easily identify and locate the dot by the contrasting area. Dots printed right on the edge can be a problem to locate because the camera will see the dark shadow from the material edge's drop off. Fiducials should be placed to the outside of the cut line areas. Random placement of fiducials around the cut line is perfectly acceptable. Suggest each sheet should include 2 fiducials that are 1 inch apart, parallel to x-axis, and located near 0, 0. These locator fiducials will show the employee how the sheet should be placed on the cut bed of the machine. There can be fiducials at 3 corners per sheet, global, or 3 to 4 fiducials per square foot, local. Global fiducials provide a broad reference for images to be cut out quickly, while local fiducials provide more exacting perimeter detail for high accuracy cuts directly on the line of the graphic. Fiducials should be on a separate layer to make outputting and toolpathing files very easy. The graphic artist's final job is to save out 2 files, one for the printer and the other for the machine. The graphic file going to the printer will include the graphic layer and the filled dot fiducial layer. Graphic files being sent to the printer are commonly output in a PDF or EPS file format. The vector file going to the machine will include only the cut line layer and the wireframe fiducial layer. The vector file for the machine is commonly output as a low version 3 AI, EPS, or DXF file, Once these files are output, then the graphic artist's job is done. The graphics file that was output for the printer must first go through a RIP or raster image software before going to the printer. While a printer driver is common to most people, a RIP is an independent program that offers additional features and advanced functions not found in a standard printer driver. The RIP takes digital information about the appearance of a graphic file and then translates that image out into a composition of dots based upon the specific printer used. Once completed, the image will be printed to the product, which can then be delivered to the MultiVision machine for cutout. Before the printed product can be cut out by the multicam machine, the vector file must be processed through a CAM or computer-aided manufacturing software. This type of computer software is used to precisely control CNC machines so that workpieces can be cut from raw material. CAM software primarily takes a variety of tooling, such as a router bit or knife blade, and calculates how it will move that tool around a vector shape in order to cut the shape out. Vector coordinate information from the graphics file is retained within the CAM software and ultimately output to the multicam machine for MultiVision and cutout data. So the print is laid down randomly onto the table. The executed machine file directs the MultiVision camera out to the coordinates of the first fiducial. The camera takes a snapshot to find the real-world X and Y center of the printed fiducial. Since the print was randomly placed, the coordinates of the found printed fiducial and the graphics coordinates won't match. The difference is used to define overall placement of the sheet. The continued comparison of the other fiducials defines rotation, scale, and any printer skew. Since the graphic images were printed at the same time as the fiducials, the associated rotation, scale, and skew of the dots will directly apply to the die lines for the images. Using some fancy math, the toolpath's cut line data is remade on the fly to match the print laying on the table.